Okay, brand new topic. This is circles, and this is moving away from just dealing with finding the circumference, finding the area, radius, diameter, moving away from all of that. This is dealing with the equations of circles, okay? So similar to the way we can get the equation of a straight line or a curve, we can get the equation of a circle. And what that equation does is similar to what we do when we're dealing with straight lines and curves, is that it gives a connection between the x and the y value of any point on that circle. So if we were to take a circle and plot it on a set of axes, the equation of that circle marks a formula or a connection between the x and the y coordinate of every single point on that circle, okay, but on the edge of that circle. Okay, obviously when we're dealing with circles, we think about a center. That's not on the edge of the circle. However, it plays a big part in the actual equation of a circle, okay? So having done radii, diameter, circumference, and areas of circles, we're now going to look at the equation of one, as I just said. The equation can take two different forms, and these are both actually given in your formula sheet, okay? I'm going to start with one and move on to the other, but they're both quite important. They're both kind of used and can be both used in the exam, and you obviously need to know the difference between them and how and when to use both of them. So the first one, okay, is x minus a all squared plus y minus b all squared equal to r squared. Okay, so kind of link into what I said earlier. Obviously, it's a connection between an x and a y, so they're going to be in the equation. The a, the b, and the r here are going to be replaced by numbers, and they obviously stand for something specific. AB is an actual point, it's the center of the circle, whereas R is obviously just the radius. Okay, so it's actually a very straightforward formula, and it's used, as I say, to mark or show the equation of a circle. Okay, so a useful formula for finding the radius or any distance between 2 points. So this is just a whole separate formula entirely, but it links very closely, very closely to this formula. Okay, and it will give the distance between any 2 points. Namely, if we wanted it, the radius, the center, and a point on the edge of the circle. And that's x2 minus x1, okay, squared plus y1 minus y2, or y2 minus y1, that should actually be squared, equal to the distance squared. So you look to that to an extent where you're doing straight line, and if you actually notice, these two formulas are virtually the same. And that's actually where the kind of the circle formula comes from, okay. At the end of the day, it's just a version of Pythagoras, but it allows us to get the equation of a circle as well. But don't confuse it with the midpoint formula. It's similar in a way to midpoint formula, but just the negatives are perhaps slightly different. So don't get the two of them confused. The bottom line is this formula will actually be in your formula sheet, okay? And you can use it if you actually wanted to find the distance between 2 points, okay? You can use that circle formula and just replace basically the letters with the appropriate letters with points that you're trying to find the distance between. The distance between the two x's squared plus distance between the two y squared will equal r squared. As I say, it's just basically Pythagoras. We're going to use it though in terms of circles. We're going to use it in a very basic manner to start with, okay? So we're just looking at this. This is just going to be the connection between the different parts of a circle and its equation. Okay, so in the most simple way possible, we're just going to write, first of all, the equation of a circle with center 2 minus 5, that has a radius of 6. Okay, so they're the main things that change. It's basically the position on the actual axis. Set of axes is going to change. That's dictated by the center, and then obviously how big or small that circle is dictated by the radius. So as long as we can get those two into our equation, then we can give the equation of any circle, okay? But when we have our basic formula, and as I say, this is just a new formula sheet, it's just a case of substituting these values in. Your A is 2, your B is minus 5, and your R is 6, okay? So just put them in and just be careful with your negatives. Obviously, it's going to be y minus 5 all squared, and y minus 5 all squared is outside the brackets, so we can just change the two minuses to a plus. We don't need to work that through. We're going to look at that in a minute, but just now, that's fine as the equation. That's all we want. That is the connection in one of its simplest forms in a perfectly simple version, so that's absolutely fine as it is. So then the reverse of that is to take the equation of a circle, and actually find what the radius is and find what the center is. Okay, so here we have x plus 4 all squared plus y minus 1 all squared equal to 9. So the center is going to be to do with the numbers in the brackets. Okay, and again, just be careful with your negatives because it's minus in the first instance. If you go back to looking at this one here, okay, it's x minus a squared. Given that we have x plus 4 here, that means that the first point is minus 4. Okay, for the second one, it's just 1, and then the radius will be the square root of what it's all equal to. So as long as it's in this form, then the square root of this number here will be our radius. So it's just the square root of 9, which is 3. Okay. All right, this last one's a little bit different, but the point is we can use the equation, the general, this equation of a circle to find the equation of the actual circle. So find the equation of the circle which passes through the point 74 and has center 4, 2. The idea is this point 74 just has to show a point on the circle. So that's going to be our x and our y. Okay, the 4, 2 is the center, so that's going to be our a and our b. Okay, so then it's just a case of substituting them in to the equation and working out what it will be in terms of the radius, and then we can substitute it back in. So it's going to be 7 minus 4 squared plus 4 minus 2 squared will equal whatever r squared is. So 7 minus 4 is 3, 4 minus 2 is 2, 3 squared and 2 squared gives us a total of 13. So the radius is root 13, but the point is in the actual equation, we don't want to know what the radius is. We actually need to know what radius squared is. So we don't need to worry about square rooting. We can just write x minus 4 squared plus y minus 2 squared equals 13, making sure that these numbers here are the center and not the point on the outside. Okay? Right, this leads us into the second version of the formula, which actually is just basically what we had multiplied out. Okay, so if we were to take the previous equation, x minus a squared plus y minus b squared equals r squared, and multiply it out, shift it all to one side, then we'd have something along these lines. Okay, again, this is given in your formula sheet, so you don't need to worry about it too much. You just got to be very, very careful again with the negatives here. So if you know what g is, minus g minus f similarly is the center, and then the square root of g squared plus f squared minus c gives the radius. Right, there's plenty of proofs for this. As I say, if you multiplied out what we had previously, then you could work this out yourselves. But the bottom line is you might have this version of the formula sometimes, and if you do, it's a case of reading off however many x's you have, in other words, the coefficient of the x's, dividing it by 2, and then changing the symbol of it. That'll give you the first part of your center, and then likewise with the coefficient of your y. Okay, and then you can use the two values along with the c value at the end to find out what the radius is. Okay, so this bit's important here, and this is quite often used as kind of a problem-solving question. Okay, show why perhaps this isn't a circle. Show why this formula cannot be a circle. Just because it looks like that, just because it looks like the version I've just highlighted, it doesn't mean it is a circle. So we prove that it is a circle by showing that g squared plus f squared minus c, all square rooted, is greater than 0. Okay, the point is if it's less than 0, then it's given that it's dictating, it's actually showing us a length. We can't have a length that's less than 0, in which case it can't be an actual circle because it can't be a radius. Okay, so this formula will be given to you in your formula sheet, so you don't need to memorize it, but the note will not. If required to prove a circle is a circle, this is important. Okay, so that's what the formula sheet looks like. So you've got both versions. Okay, and that's all that's given to you. So this bit here, this little note isn't given to you. That's just worth remembering. So a radius obviously is only a radius if it's a positive number or if it's basically bigger than 0, because obviously it can't be 0 as itself. As long as it's bigger than 0, then it is actually a circle. So vice versa, if you want to prove something's not a circle, then prove that the radius is negative. Okay, right. Find the center and radius of the circle with equation x squared plus y squared minus 4x plus 2y plus 1 equal to 0. So now it's just a case, and you can use your formula sheet for this, you don't need to memorize this, but it's a case of obtaining these three numbers. Okay, so it's the coefficient of x, the coefficient of y, and then the bit floating around at the end, basically. So we can say that 2g must be the coefficient of x, so 2g is equal to minus 4, and likewise with 2f. But once we know what 2g is, we can find out what 1g is, okay? Once we know what 2f is, we can find out what 1f is, and we've just got to be careful with the symbols. They basically just swap round, okay? If it's minus 2, then our center is going to be positive 2. With the f, if it's 1, then our center is going to be minus 1, okay? So just swap those symbols around, but all of that is clear in your formula sheet, okay? So pay attention to that. Now, in terms of finding the radius, we take those two numbers, and it doesn't necessarily matter which ones we pick, but because we're going to be squaring them, but technically we're supposed to pick the g and the f. So the g squared plus the f squared minus the c value at the end, all square rooted, will give us the center, okay? So we put them into the formula, which is again given to you in your formula sheet. So g squared minus 2 squared plus 1 squared, that's our f, and then take away the c value at the end. Once we square root that, we get 2. That's the radius of our circle, okay? So this second one is basically showing that a circle is a circle, or perhaps that it's not a circle. And we do that by proving that it's either got a radius, or in other words, it's got a positive length for its radius. If it's got a 0 radius, or a negative length, then it cannot be a circle. As much as it may look like a circle, you can just shove numbers in here and it's not actually a circle that it's representing, okay? So if we take, basically we don't want, it doesn't matter where the center is. The center will always exist. We just need to actually find out if the radius is basically greater than 0. So we need to still find our g and our f. So 2g is our coefficient of x, 2f is our coefficient of y. So g is basically -1 and f is 3. And if we plug that in with the c to our radius formula, this isn't important, the center isn't important, it's just the next bit. So -1 squared plus 3 squared minus 15, -1 squared is 1, 3 squared is 9. 1 and 9 makes 10, take away the 15 is -5. We can't find the square root of -5, in which case we can't have a radius, in which case we cannot have a circle. So we've got to just write this nice and clearly. G squared plus f squared minus c is less than 0. Therefore, the equation x squared plus y squared minus 4x does not represent a circle. Okay. All right, so third question now. Circle x squared plus y squared plus 4x minus 2y minus 84 equals 0 has diameter AB, where A is -10, -4. We're going to find the coordinates of B. So what we've basically got here is we've got a situation, okay, where we've got a circle, we've got a diameter, we know one point, and we were trying to find this point here, okay? So we're taking all the information that we've got and trying to find basically the point opposite this. Right, this is going to involve a very important method that we're going to use quite a lot in circles. It seems like a very basic old school method, but it's actually the easiest one to use. If you don't use this one, you're using something along the lines of vectors, which is just too much of a faff. So I suggest you stick with this. It's what we call the stepping on method, okay? But the first thing we're going to do basically is going to find the center. So because we have the circle equation, we can find the center. So 2g is 4, in which case g is 2. 2f is -2, in which case f is -1. So I can find my center is -2, +1. Right, I'm drawing a wee picture now. And this is the situation that I've got, okay? So I have my A value, that's -10, -4. Okay, I have my center, C. And what I know, because I've got this same distance, so if I'm using my diagram up here, I've basically got this distance here, or this length here. I know it's exactly the same on the other side, because every radius in a circle is exactly the same. No matter where it is within that circle, it's the same radius. So what I'm basically saying is I've got the same on the other side. And I basically need to step on in the same way from the center to the right and up. So I'm using these values that I've got. I've got -10 and -2 for my x values, and that's going to show me basically how far I've moved horizontally. And then obviously my y values show me how far I've moved vertically, okay? The idea is from the center to the right and up, I'm going to make that exact same step. So to find B, I'm basically going from -10 to -2. That's a step of 8. Okay, you can use maths, you can actually use arithmetic to do that if you want to, in which case it's -2 minus -10, or you can just think about it. Think about a number line, think about a thermometer, whatever it is. You can see we stepped on horizontally a distance of 8. So then we're going to do another step of 8 to get in line with B, but it's not going to give us our vertical step, so we need to take care of that one as well by looking at the y coordinates, okay? So we've gone from -4 to 1. That basically gives us a step of 5. Again, you can use the maths and do 1 minus -4, or you can just look at the numbers and work out for yourself. But it basically means that vertically, we need to step up another 5. So we've come along 8, we've gone up 5, and we want to do that exact step again, okay? Because we're going from the center to the other side, because this whole line here is our radius. So we're going to step on along another 8, up another 5, and then basically just look at how that affects this coordinate here. If we go 8 along from C, that's going to give us 6. If we step 5 up from 1, it also gives us 6. That's just coincidence, okay? But we've done that step. Along 8, up 5, now we found out where B is. As I say, it seems very old school, but it's the best way of doing this. Just think about those coordinates and think about what it means in terms of the circle.